Hey kids, time to do some review for the unit test, but I want to not stress you out with the problems that I'm going to do. These problems are review of a bunch of stuff we've done this unit, but they're the first 1 through 5 are straight up AP problems. So you are not going to have a test. Remember, AP writes very good questions where they have multiple objectives wrapped up in one problem. We are not going to do, right? You're going to get a test where you're tested on improper integrals and then a test on numerics. And then a question on numeric series or whatever. It's not going to be as involved as 1 through 5. So please don't let these harder problems stress you out like, oh my God, I'm not going to be ready for the test. Then there are 3 Lagrange practice ones. And I'm going to do 2 of them. And that's a pretty stereotypical test question on Lagrange. And then 10 through, I don't know what, but the rest are radius of convergence practice. So I'm not going to do those in this video because I feel like they're, they're easy to just look at the key and follow. But I want to talk about my thinking process with each one of these more challenging problems, especially 1 through 5. Okay. So when I look at this is just a multiple choice. 1 is multiple choice, talks about a Taylor series, so I better be given a center. They're not going to ask me for the interval of convergence. I've got it. But they are asking me about a polynomial approximator. They throw in k's here, which is a little annoying. But I notice it's alternating. They ask me for the smallest number m. I wonder what that is. For which the alternating series, yep, I knew that. Oh, error bound. Alternating series estimation theorem gives me the error bound. Alternating series estimation theorem gives me the error bound. And the alternating series estimation theorem just says use the first unused term to find the bound. So where's the, here, right? Do you see what I did? I was looking for the first unused terms. Well, how many terms did they use? This is an error expression. The error is, right, absolute value of fact minus fiction. So they used the 4th order polynomial at what number? 1. Can I use 1? Look at your interval of convergence. Oh yeah, my center is 0, but I'm at the interval of convergence includes 1. So I'm plugging 1 into the function. No, I'm not. I'm actually plugging 1 into the predictor, right? And I want to know when I do that, what's the worst case scenario? Because my series is alternating, I can just find the next term. Is 5th order. So go to the k's, right, since they're using k's for some reason, and replace all k's with 5. And I'm not going to use the alternator because it's absolute value. So kx to the k squared plus k plus 1. My denominator is 31. So hopefully now you probably already see your answer. What do you plug in for x? What x are they asking me to plug in? 1. Done. Average of 2 minutes. It took me less than 2 minutes. All because I didn't let the number of words and the fancy mathy stuff in there freak me out. I saw alternating series error bound that made me think ace it. I just need the next term. What's the next term? plug in 5, right? Plug in the x that they're asking you to approximate, done and done. Number 2 is going to take me longer than 2 minutes. I have an improper integral. For what value of k is any improper integral? So here's my strategy. An improper integral means I'm going to have to take the limit and no, I didn't forget about k. I'm going to osmosis that k out here, all the way out. I'm not going to worry about that k until I evaluate this improper integral, because they want to know, does that improper integral equal 1? So my strategy is to evaluate the limit first. Evaluate the integral first, evaluate the limit second, and then say what k times that evaluated integral with the limit is equal to 1. So that's my strategy. So the first thing I do is look at this integral. Notice it's a product. Product means unproduct. Nope, can't do it. Means u substitution. If u is negative 2x, the derivative is negative 2, still have an extra x. Dagger, take a moment and cry, because I can't unproduct that, which means I have to do integration by parts. Integration by parts takes lipit. Lipit helps choose your u, polynomial u. The rest of it then is dv. So I'm going to go over here. U is equal to x. dv is equal to e to the negative 2x. du is equal to 1 dx. And v is equal to negative 1/2 e to the negative 2x. Notice I've forgotten all about k and the limit right now. Oh, I should put this though. So the integration by parts formula says this integral of u dv is equal to u times v minus the integral of v du at 0 and a. So step 1 still not done. Got to plug in 0 and a. So I have negative 1/2 a. I'm going to bring those exponents down. Minus negative 1/2 times 0, so don't care about the rest, minus 1/4 e to the negative 2 times 0, which is e to the 0. Now I'm going to apply the limit. So step 1 is done. Now apply the limit as a approaches infinity, right? So if a approaches infinity, this is 1 over infinity, which goes to 0. This unfortunately takes a little bit of L'Hopital's, right? Because this is really infinity over infinity. So L'Hopital that, and I get negative 1/2 times the derivative of a, which is 1. And the derivative of e to the 2a is 2 e to the 2a. Now apply the limit. The limit, again, just has negative 1 in the numerator and then infinity in the denominator, so that goes to 0. So this whole piece goes to 0, and I am left with negative 1/4. Done the limit part, so step 2 is done. And I can plug 1/4 into here, solve for k, and k is equal to 4. That took me longer than 2 minutes. The next problem is going to take me longer than 2 minutes as well. First thing I notice is that they are talking about a series, but they don't say Taylor or Maclaurin, and there's no x. So this is a numeric series. So the numeric series either converges or diverges, but they want to know if it does converge it converge absolutely or conditionally? C and D are really the same state, right? So my first thing is, does this series converge? Well, it's alternating. So all I need to know is, do the terms go to zero without the alternator? And are they all positive without the alternator? Yes. So by the alternating series test, this numeric series converges by the alternating series test. So I can eliminate diverging. And as soon as your alternating series converges, it converges conditionally. So that choice is out. So my answer is either going to be B if I can say that it does not converge absolutely. How do you test for that? You take the absolute value of the series, right? So the absolute value of the series, take this absolute value, the alternator goes away, and you just have 1 over 1 plus n to the 1/2. This is multiple choice. I don't have to write out everything. I just have to think to myself, I'm going to need a comparison. I'm going to compare to the kissing cousin, n to the 1/2. N to the 1/2 diverges. P is less than 1. I'm not going to worry about size, right? I'm just going to do, position. I'm going to do the limit comparison test. The limit as n approaches infinity of my known function compared to my unknown. I'm going to reciprocate that. I think you can see I'm going to get powers that are the same. So the ratio of the coefficients of both of those n to the 1/2 is 1. 1 is between 0 and infinity, therefore both do the same, therefore both series diverge, which means that as soon as you take the alternator away, the given series, which converged by the alternating series test, the minute you take out the alternator, you get diverging. Therefore, the series does not converge when you use absolute value. Therefore, my answer is B. That did take me a little bit longer than 2 minutes. Number 2 took the longest. All right, let's look at number 4. Number 4 is giving me a table, selected values, first 3 derivatives, third degree Taylor polynomial about the center 1. So I don't think I'm going to deal with the 0 and the 2, right? Taylor's formula says, and third degree doesn't always go with third order, but it does unless when you haven't manipulated anything. So anyway, it's the original function, right? No derivative evaluated at the center. I hope you can see that there is one choice you can eliminate right away. Do you see it? Whoops, why did I put a 2 there? Third degree. All right, so what do I need to go figure out? What the choice A is out. There's no x minus 1. It says the center is 0, but the center is 1. So that's out. Then the next thing I need to know is at the center 0, the original function at the center was 2. And then, of course, I have x minus 1 to the 0 is 0 factorial. So the first term oh, darn, they all have 2. All right, the next term has the derivative -3 divided by 1 factorial, x minus 1 to the first. Oh, crap, they all have that too. The next term has the second derivative 3 divided by 2 factorial. Ah, somebody's out. You see who it is? They just have the 3 in front of the squared term. So the third term has to be +3 divided by 2 factorial, and then x minus 1 squared. Still have 2 left. My next coefficient is -2 divided by 3 factorial. Which one is that? Negative 3 divided by 3 factorial. I'm sorry, negative 2 divided by 2 factorial is negative 1/3. So that choice is B. That one didn't take me. That one took me maybe about 2 minutes. But I had to know Taylor's formula pretty well. All right, this AP problem is a doozy. Please, I will not do this to you. I will not do this nasty one to you on the test, but it's good to see. Okay, it's good to see because it has a lot of stuff wrapped up in it. So the first thing to realize is this thing starts at 2, which means that your first, right, when n is equal to 0 must have been 0. When n is equal to 1 must be equal to 0. And then I had ln of 2. And I know where this problem is going, so that's why I'm bothering to write this out. So since I saw that in part A, they were asking for derivatives of a function I don't see, I just see its series. Hopefully the first one isn't too bad to realize what it must have been. But the fourth coefficient is not the fourth derivative. Is not the fourth derivative, right? That's a test to see if you know Taylor's formula. Certainly, since I don't have any term here, the first derivative must have been 0. But remember, by Taylor's formula, the coefficient of x to the fourth is the fourth derivative over 4 factorial. This is the coefficient of x to the fourth. So, how do I go from the coefficient to just the derivative? You have to multiply the coefficient, right? This is the coefficient, the fourth coefficient of x to the fourth in the box. So to get just the fourth derivative, you need to multiply the coefficient by 4 factorial. You know what that looks like? I mean, if you have a calculator, go ahead, but there's no need. You don't have to simplify anything in free response. Done and done. Now, part B says, does f have a min, max, or neither at the center justify? Anytime someone says a max or a min to you on the AP exam, you think derivative test for extrema. And if you are in series, please think the second derivative test for extrema, because you can't, right, solve for the x that makes take the first derivative, solve for the x that makes 0 and test when you have an infinite series. So you think the second derivative test for extrema, which says if you have the first derivative equal to 0, hello. And the second derivative is either positive or negative. Well, where's the second derivative? The second derivative, remember, we've been through this before. That's not the second derivative. What's the second derivative? It is the coefficient of x squared times 2 factorial. But can you tell that that is positive? I don't actually care its number. It's positive. Therefore, f is concave up and has a horizontal tangent. And with a horizontal tangent and being concave up, you must have a local min. And there's all my justification as well. Done. If you can do those two parts on an AP exam, you've got a decent amount of points for this problem, right? You've probably got about half of them. You probably have 4 points there. And remember each one. So part C might be worth 5, might be worth 4 points, and it's a dagger to lose those. So don't lose them all. Do the ratio test. Now, I know that this is asking me for the interval of convergence, which means I have to do endpoints. And an endpoint analysis is going to take a lot of work. On an AP exam, I might bail at that point, but I do know how to do the ratio test. This is why we made you do a bunch of them. Do it quickly. Now, this one is involved. This one is a little bit more challenging than some of the ones that you've done before, but nevertheless, if you set it up, you're certainly going to get a point. So what do I have? I have ln n plus 1 and 3 to the n plus 1, n plus 1 to the third, and then x to the n plus 1 times the reciprocal. And then you know what's going to happen with that. With the x is going to come out front. Right, so I'm going to deal with that. The 3 to the n is going to go away and leave a 3 down there. I'm going to gather my ln's together. Whoops. Whoa, my pen just freaked out. So remember, the limit of a product, unlike derivatives, the limit of a product is the product of the limits. Hopefully you can see that that part is a third. This part is a little harder to see. I kind of sort of need L'Hopital's on it, right? This is 1 over the derivative of the numerator, and this is derivative of that, and that limit goes to 1. So I have the absolute value of x times 1/3 being less than 1, which means by the radius of convergence, right? My radius of convergence is 3. With a center of 0, I now have x is between -3 and 3. Now you probably have 7 points of the 9. There's probably only 2 to 3 more points in the endpoint analysis, so decide if you want to do that on the AP exam, because it's a bit of a show. Right, to do the endpoint analysis, so I'm going to erase all this so I can do it up here. The endpoint analysis, you put -3. Since my radius of convergence was 3, I'm going to put -3 into the series. And then I have ln n over n cubed and 3 to the n. This is going to be a sign alternator, is going to come out front. The 3 to the n's are going to cancel out. ln of n over n cubed. Sign alternator, these things are positive. The denominator is getting much bigger, it's getting much smaller. These are going to 0, so converges by the alternating series test. But then when I put 3 in, 3 to the n's are going to cancel out, and I'm just left with ln n over n cubed. They go to 0, but that's not enough to do, right, to say convergence for this series. So I'm going to compare. ln n is close to n, enough to compare, which is 1 over n squared. 1 over n squared converges because it's a p series. P is greater than 1. With only n squared and n cubed here, it is pretty easy to say that 1 over n squared is going to be bigger than ln n over n cubed for starting at some n. Therefore, converges to, by the direct comparison test. Therefore, my interval of convergence includes both endpoints. My justification is what I just did. Plugged in -3, got a series that I said converged by the alternating series test, plugged in 3, did comparison work, kind of spelled it out, even kind of as, right? I kind of scribbled and went through this fast on purpose because I only had, on an AP exam, I know there can only be a couple more points available for this. So I'm just kind of putting down, I'm not being really thorough or anything, and maybe, right, they want to see a little bit more, but I know I've got something, and then I'm going to move on. Okay. All right. Again, won't do a problem like this on the unit test. It will not. Are you going to have to know how to do a comparison test? Yes. Are you going to, but one like the quiz? Are you going to have to know how to do work with series? Yes. Right? Might you have to do the second derivative test or realize to do that? Right? And talk about the first derivative being 0 and the second derivative being positive or negative? You might. But I'm not going to do some kind of are you going to have to do interval of convergence? Yes. Are you going to have to do ratio test? Yes. But they're going to be a little more straightforward than like the ones that you've done for homework. Okay. So I don't want you to freak out too much. You want to practice harder problems, prepare for the worst, and hope for the best. All right. I just wanted to erase that because I want to practice the Lagrange. Remember, I told you 6 through 8. I don't know if I said 6 through 8, but anyway, 6 through 8 are Lagrange. So let's practice the Lagrange remainder. So they're asking for the maximum error when we use an approximator of root x on this interval. So third power goes with third degree. So my remainder bound after using the third order polynomial is less than or equal to some mysterious m over the next factorial this is going to be x minus my center. What's my center? -1, good. And then this is the x that they want me to approximate. To the what power? The next power. So that's the formula. We're not going to give you the formula. You do. AP won't either. Okay, so you need to know that formula. It really is the next term, right? It's the next term, the next factorial, the next power, and the only thing about this, it is the next derivative. M is the max of the next derivative, though. Absolute value of the next derivative on the given interval. You're going to use your calculator for this. So annoyingly, you have to find all the derivatives. Psi. So since I need the fifth derivative, oh, sorry, no, not the fifth, the fourth, you silly. I have to say, well, f first derivative, good thing I took second derivative, third derivative, fourth derivative. And I need to take you're going to put this in y1. Did I do my signs right? X to the 1/2, positive. Oh no, I think I messed up my signs, right? Because when I pull this down, this one's going to be negative. That's going to be positive. This is going to be negative. Not that it really matters because I'm going to take absolute value. So you're going to put this into your calculator. You're going to put that function in y1 and look for the max. Okay. Whatever the max, you're going to use your calculator and find the maximum on this interval, right? Now, this is all root x stuff, so it's either going to increase or decrease. So it's going to be one of the endpoints. Look at your calculator. I didn't draw it and see what it was. And you are going to, that number that you found, which is either going to be at 0.8 or 1.2, is going to be m. And again, I didn't write down which one it was, but I got 2.047-ish over 4 factorial. Regardless of whether you put 0.8 or 1.2 in here, this is going to be, and you're going to absolute value it, so it's going to be 0.2. And you're going to do that on the calculator, and you're going to get your bound. And your error in using the third order polynomial to approximate will be 0.000135-ish. Okay. So that's going through Lagrange when I have to actually find these derivatives. So I'm not going to go through the next one. I'm just going to set it up for you. It is a third order approximating tangent, right? And they want the maximum error when approximating on this interval. So again, you're dealing with what is the remainder after the third order? M over the next factorial. The center is 0, and it's going to be the absolute value of the farthest here. So that's going to be 0.5 to the 4th, where m is the maximum of the absolute value of the 4th derivative of tangent. So you need to say f of x is tangent. F prime is equal to secant squared. So this problem is a bit nasty. No, I won't do this one to you on the test because you can see to find the second derivative, you need the product rule. So this is going to be a bit nasty. I won't do it on the test, but it's good practice. I could do one like the square root of x. This is Lagrange backwards. So I just wanted to highlight that one. For what values of x will the error be less than that number? So this is Lagrange backwards. This is 4th order. So, and remember the trick with sine and cosine? The 4th order polynomial is the same as the 5th order polynomial because the derivative there is 0. So I'm going to say the remainder after using the 5th order will be less than or equal to this maximum, which by the way, for sine or cosine, I'm just going to make 1. over the next factorial times I don't know what x. That's what I'm after. For what values of x to the 6th power? And again, with sine or cosine, what's the maximum of the fifth, the first, second, third, fourth, fifth derivatives, right? They're all sines and cosines. What's their maximum? 1. So they gave me the remainder bound. Do some algebra. So the absolute value of x .0001 times 6 factorial and all to the 6th power. And I did that on my calculator and I got 0.644. Oops, 6 or 645, whichever. Sorry, I have this inequality backwards, I think. I don't want to know greater than. Oh, what happened there? It's going to be between. All right. So like I said, I'm not going to go through, I said 10, but I meant 9. I'm not going to go through these problems because they are all radius of convergence problems, which means no endpoint analysis. You just do the ratio test. When you do the ratio test, don't forget that the very first thing you do is write limit, right? And then do your, right, n plus 1s times the reciprocal of just the n's, and then show me some math, and then give me the radius of convergence is blank, and in that blank, you're either going to put a number or you're going to put infinity, right? You love when the radius of convergence is infinite. You hate when the radius of convergence is the number 0. You're okay with the fact when the radius of convergence is 5 or 6. And don't forget your centers, right? This one, your center is 0. This one, your center is 2, 0, 0, -1, right? All right. That is enough review for now. And we will do some more like kind of straightforward review problems with the review packet that we end up collecting. Okay? Have a good one, and I will see you then.